Liquids. This is the first section of chapter 17, liquids. A few things to review, remember from chapter 15 is the kinetic theory, which had three main points. All matter is made up of small particles. Those particles are in constant random motion. And they collide with each other and the walls of their container. And so that's going to be the foundation of this chapter as well. Pressure is also going to be a very common topic. We can kind of define pressure two different ways. Force per unit area, and that pressure is measured in pascals, which we often, 1 pascal is really small, so we often end up using the kilopascal, which is of course 1,000 pascals. So one way to think about pressure is force per unit area. Another way is to realize that pressure is the result of the particles colliding with the wall of their container. Particles collide. And third thing to review and to keep in mind throughout this chapter is that temperature is more than just how hot or cold something is. Our definition is the average kinetic energy of a substance. And kinetic energy is all about particle speed. So fast particles means higher temperature, and of course the opposite is true as well. Slow moving particles means a lower temperature. Okay, so those are some three main things that we want to keep in mind throughout this chapter as well. So liquids, we know they have the ability to flow, which means the particles can move past each other. We know that they have no specific shape. It's often said they have take the shape of their container. And they do have a definite volume. Of course, that will change with temperature, but at a specific temperature, their volume is definite. So liquids, of course, is this middle phase right here. the phase where the particles are as far away as they're going to get is the gaseous phase, and then solid is the very rigid structure. We are going to talk conversion. We're going to start out at the liquid phase, and then we're going to turn liquids into gases, and then liquids into solids, and vice versa. So we have a few words to add here. When something is converted from a solid to a liquid, it is known as melting. When it is converted from a liquid to a gas, it's known as vaporization. And that might not be the first word that came to mind. And vaporization happens two separate ways. We can boil the substance, boiling, or evaporating. And we'll talk about each of those a little bit later. But they're both known as vaporization, transition from a liquid to a gas. And then when we go the other way, and I just realized that my arrows are upside down, and I think I can't really fix it right now. So anyway, the conversion from a gas to a liquid is known as condensation. And then the conversion from a liquid to a solid is freezing. There's one more that's always kind of fun to talk about. It is possible for some substances to pass over the liquid stage and go from a solid straight to a gas, such as dry ice. And this process is called sublimation, when it skips the liquid phase. Okay, so we have melting and freezing, and these two things we're going to talk about together because they are essentially the same thing. They happen at the same temperature, but opposite transfer of energy. When something melts, the energy is used to increase the temperature. When something freezes, the energy is leaving, so the temperature is decreasing. So that's why we kind of put them together, even though they seem, and they are, very opposite reactions, but they're more similar than they appear. So almost all solids and liquids expand when the temperature increases. Of course, the one exception, that's why we say almost all, the one exception to this is, of course, water. And we talk about water, I think, in the next section. We talk all about water. So right now we're going to focus on everything except for water. So we have expansion that happens in almost all solids and liquids when temperature increases, because increased temperature means the particles are moving faster. Again, temperature is the average kinetic energy, so faster means a higher average kinetic energy. Faster moving particles means they are going to have more frequent and more violent collisions. These definitely are connecting. More frequent and violent collisions. And you can see this in everyday life. If you're moving faster and you run into a wall, it's going to hurt more the faster you run into that wall. If you just kind of are walking slowly and bump into the wall, no big deal. If you are sprinting for some reason and run into a wall, it's probably going to hurt quite a bit more. More frequent and more violent collisions means the particles bounce off each other and move farther apart. When particles move far enough apart that they are able to move past each other, we say they have officially begun to melt. The solid has become a liquid. And that's how it happens. That's the simplest we can make it. Again, note that we could rewrite all of this and use the opposing terms and make it true for when a substance freezes. So real quickly, if we want to talk freezing, we have to flip our words around. Almost all solids and liquids contract when temperature decreases, because a decreased temperature means the particles are moving slower. Slower moving particles means less frequent and less violent collisions. Less frequent and less violent collisions means the particles bounce off each other, but do not move very far apart, which means they are no longer able to slip past each other, which then means they're a solid, so they are frozen. And that's what that would sound like. Not going to rewrite that, obviously, but we could. Our official definition for the melting point is what we're going to put right down here. So our melting point is the temperature at which the vapor pressure of the solid and liquid are equal. And that, of course, is a very technical definition. We'll talk more about vapor pressure in this next page, which is called vapor equilibrium.